So we were talking about the feathers on these specimens. I've got a few example feathers here. These I think are mostly from geese. Just showing you some of the details of the feathers. These two large ones here are very typical flight feathers. So this one here is a primary. A couple of kind of noticeable aspects of flight feathers, ones that are made for flight, is they tend to be very asymmetrical. So here we've got kind of a larger kind of vein on the posterior side of the feather, the narrower vein on the kind of leading edge of the feather. And these veins, of course, are made by lots of little barbs that are all hooked together by the barbules. So you can see here we've got a very solid rachis. In this case, the tip of this feather down here by my finger, this would actually swivel on little bumps in the bone, and this would be firmly attached to the skin, and by pulling on that skin, they're able to actually move the feather, pivot it around. And that way they can affect the shape of their wing, right, the shape of their airfoil. A couple of other kind of noticeable things, as you might be able to see that on the leading vein, it's kind of thicker here, and then there's a dip, and it gets thinner. That's called an emargination. Similarly, on the trailing edge, you can see it's wider here at the base, and then gets, again, thinner as you go to the top. This is an emargination. This one's called a notch. And the reason they have those is basically when the flight feathers are together, they make basically one kind of constant surface, but this means that they can move them out and create little gaps in the feathers. And they can actually kind of raise and lower the feathers to adjust then the airflow through those. And that lets them really fine-tune kind of how air is flowing over the wing and lets them have very fine control. This is particularly common on birds that fly slowly or that soar. Soaring birds have very deep notches so that they can basically almost like, wiggle their feathers. They can wiggle their fingers. These feathers can get kind of moved to affect fine-scale airflow. So these two are probably primaries. This feather here, again, it's less asymmetrical, but still some asymmetry here. This is probably a secondary. Maybe it's a rectress, but my guess is it's a secondary. Most rectrices are more symmetrical. But again, this is now going to be kind of tailing on the bottom side of the wing, forming the airfoil with these kind of overlapping. And if you look at the shape and profile, you can see they're kind of meant to overlap. So you've got kind of a concave versus a convex leading edge versus trailing edge. That means they fit together very nicely. So those are the flight feathers. Then we have the body feathers, which include contour feathers. And then this feather here I wanted to show you, this is a semi-plume. So you can see at the top we have a feather that basically looks like a contour feather. At the bottom we have this very fluffy stuff that looks like down. And that's exactly what it is, right? So we'll have down close to the body forming an insulating layer. We'll have contour feathers creating a nice smooth surface on the outer part of the body. And then these feathers are kind of in between, where the down here is for insulation, but then it overlaps with other feathers and starts to provide the form that the contour feathers would provide.
So let's take a look at a feather under the microscope, and we'll start with a semi-plume so we can look at some down. If we look at the down very carefully, we can see that it's very fluffy, very filamentous. We can see the barbs here, but there's no barbules on the edge, so again, it's not going to stick together. So let's play with it a bit. So here we're seeing another view where I'll tease it here with a probe. And you can see as I'm moving the elements of the feathers around, there's really no cohesion, right? This is just fluff. Lots of fluff, though, and you can see lots of air gets trapped within the structure here. So it makes it great for insulation, but it doesn't give the feather much structure. And if we zoom in really close here, you can just see how smooth these barbs are, right? Nothing to really connect. Now, if instead we look at a rim image, so here, this is more typical of a contour feather or a flight feather. Now when we look really closely, we can see there's a lot more structure, right? We can see that on those barbs we have these little barbules, so that means there can be more cohesion. So here we're looking at one of the surfaces of the feather. We'll probe it with the probe again. And you can see that as I move this around, those barbs are now moving together. They're stuck together, right? And it's really done by those little barbules, which act kind of like Velcro. So here we've got a slightly different view here. And now, I'm going to actually tear kind of those barbs apart. So I'm using that probe to kind of unzip the barbules, and you can see now I've got kind of a gash in the surface of the feather. We'll pull that apart a little bit, and then let's zoom in and take a closer look at what this feather has going on here. Let me get this lined up and focused. Okay, so now we can see up close right where that separation occurred. And you can start to see the little barbs have little serrations, the barbules, have little serrations on them. You can almost see these little hair-like structures on those filaments. That, like I said, is basically going to act like Velcro. And so as I kind of move and tease this, you'll see that they're kind of holding together even, as I apply some pressure on them. You pull hard enough, you can separate them, but they do stick pretty well. And importantly for the bird, these can be repaired. So here, if I squish the feather back together, you can see that those little barbules reattach to one another. So kind of, Velcro. And this is just me using my finger. Birds have a lot more practice. But here, as we zoom out, you can see that gash I created has now been kind of reattached and sealed. If I use the probe to kind of move this around again, you'll see that, again, they're adhered together. So now that surface can withstand some pulling and tugging, and you'll see that these barbs are going to remain together. So let me get the probe here. And you can see now they're kind of sticking together. And you can kind of see a little area, where I initially opened it. I can kind of smooth it out a little bit. But, with a little coaxing and smoothing, you can see that, these basically seal right back.